Hello friends, this is electronic configuration. What is definition of configuration? Configuration means distribution. Distribution of electron in different type of cell is known as electronic configuration. Here, what is electronic configuration? So distribution of electron in different type of cell with respect to requirement of cell is known as electronic configuration. So now, what is cell? The cell is orbit. Cell is nothing but it is normally known as orbit. And what about orbital? Orbital का मतलब होता है area. So whenever motion of electron will take place with respect to Cartesian coordinate system, then different type of shapes are created by this electron. Correct? So what is orbit? So whenever motion of electron will take place with respect to nucleus, here different type of shapes are created. Clear? And this shape will include, here we can say orbit as well as orbital. So whenever we are taking any single atom, the atom is constituent of electron, proton and neutron. So on the basis of these three basic fundamental particles, on the basis of these three fundamental particles, the atom will be formed here. And whenever we are taking picture of any atom, normally what will happen? Here we can say that this type of picture will come. The central part of atom is normally known as nucleus. Central part of atom is normally known as nucleus, and outside nucleus, here different orbits are there. The first orbit is represented as a K, second orbit is L. So here, in case of orbit, K, L, M, N. So these are normally known as orbit. And with respect to nucleus, number of K cell is 1, number of L cell is 2, and number of M cell is 3. Similarly, number of N cell is 4. It means outside nucleus, whenever we are going, then here K, L, M, N, different type of cells are there. Now this cell will include orbital. So what is orbital? So whenever motion of electron will take place, with respect to Cartesian coordinate system, then what will happen? Electron will create different types of shape. So on the basis of shape, here S orbital, P orbital, D orbital and F orbital will come. Again I am repeating, so whenever motion of electron will take place with respect to nucleus, here different shapes are created by this electron. And on the basis of this shape, here S orbital, P orbital, D orbital and F orbital will come. So now shape of S orbital is spherical, shape of P orbital is dumbbell, and shape of D orbital is double dumbbell. Again I am repeating, so whenever motion of electron will take place, so here different type of shapes are created. The shape of S orbital is spherical, P orbital is dumbbell and D orbital is double dumbbell. Clear? Actually see, whenever we are discussing any, we can say that here means shape, then we are accepting Cartesian coordinate system. Here we are accepting Cartesian coordinate system. On the basis of Cartesian coordinate system, the shape of S orbital will be spherical, shape of P orbital will be dumbbell and shape of D orbital will be double dumbbell. Now how many shapes are there in case of S orbital? In case of S orbital, only one figure will come. In case of P orbital, 3 figure will come, and in case of D orbital, 5 figure will be there. In case of S orbital, actually how we can remember, from 1 to 10 number is given, and out of this 1 to 10 number, you have to remember only odd number. In case of S orbital, only 1 circle. In case of P orbital, 3 circle. In case of D orbital, 5 circle will be there. Correct? So now, how we are representing this S orbital? Here you can utilize either circle or square. For simplicity purpose, I am taking here means circle. And in case of P orbital, these 3 circles will touch to each other. And in case of D orbital, the 5 circle will again we can say touch to each other. Correct? Now our next question, how orbit and orbitals are interrelated? So now see, this is cell. The cell is K, L, M, N. The number of k cell is 1. So select one orbital from beginning. That's why we are writing here this 1s. So see here, again I am repeating. The number of k is 1 with respect to nucleus. So here we are selecting 1s. Then after 2, here 2s and 2p will come. And then after 3, so now start comparison or addition. So 3s, 3p and 3d will come. And in case of n cell, 4s, 4p, 4d and 4f will be there. Now again I am repeating. In case of k, number is 1. So select one orbital from beginning. So here we are writing 1s. Then after 2, to select two orbital from beginning. So here we are writing 2s and 2p. Similarly 3s, 3p and 3d. Similarly 4s, 4p, 4d and 4f will be there. So on the basis of this distribution, we can say that orbit depends upon orbital. On the basis of this, we can say that orbit depends upon orbital, but orbital does not depends upon orbit. Now we will discuss here how distribution of electron can be done. तो मैंने आपको पहले ही बताया था कि this table is important. Here orbital S, P, D is there. The shape of S orbital is spherical. Shape of P orbital is dumbbell and shape of D orbital is double dumbbell. In case of S orbital only one figure will come. In case of P orbital 3 figure is there, and in case of D orbital 5 figure will be there. Now according to rule of Hund's rule, here in one circle maximum number of electron will be 2. This type of thing you have to remember. If number of circle is 1, then maximum number of electrons are 2. If number of circle is 1, then maximum number of electrons are 2. And here 3 circles are there, so maximum number of electrons are 6. Similarly 5, here 10 electrons are there. And whenever your electron is related with respect to this range, here your material will be stable. And suppose if your electron is related with respect to minimum means this is 2, here 1 electron will be less, here 6, so range will be 1 to 5, and here 10, so range will be 1 to 9. It means if your electron is related with respect to minimum range, then your material will be unstable. If your electron is related with respect to minimum range, your material will be unstable, and maximum range, your material will be stable here. Correct? So this is difference between stable and unstable. Now next one, if your element is unstable, then it will always try to become stable. If your element will be unstable, then to become stable, what will happen? So these elements may either donate electron or accept electron. So this material will either, we can say that, donate electron or accept electron. So whenever it will donate electron, then positive charge will come. And suppose it will accept electron, then negative charge will come. If your material or element related with respect to periodic table, it will donate electron, then positive charge, and accept electron, then here we can say that negative charge will come. Clear? So now we will discuss here electronic configuration in case of hydrogen, helium and all that. Now friends, you know, in K cell 1s is there, in L cell 2s and 2p is there, in case of M cell 3s, 3p and 3d is there. Correct? So now atomic number of hydrogen is 1. So now we are giving this 1 electron in 1s orbital. Here 1s1 will be there. Then after see helium, Z is 2. So we are writing 1s2 is there. Now see this is S orbital. So if orbital is S and number of electrons are related with minimum, your material will be unstable. Again I am repeating, S orbital 1 electron unstable, and suppose it is unstable, then to become stable it will either donate or accept. So in this way, in case of hydrogen, +1 and -1 will come. Now second one, helium, the Z is equal to 2. Now these 2 electron will be given in S orbital, so 1s2 will be there. So see, in S orbital 2 electron, S orbital 2 electron stable, S orbital 2 electron stable. So here no charges are there. But what about lithium? So Z is equal to 3. Z will represent atomic number. Z will represent atomic number. So 2 electrons will be given in 1s and then after C, total is 3. So remaining 1 electron will be added in 2s. Now what will happen? See, again s orbital, 1 electron unstable. So to become stable, here lithium will donate 1 electron. So whenever lithium will donate 1 electron, तो lithium plus 1 will be there. Similarly, देखो मैंने क्या बोला था, here 2s and 2p. What is requirement of electron in case of p orbital? तो 6. तो lithium के केस में donate करेगा तो +1 और accept किया तो कितना होगा? 6 plus 1. Here we can say 7 will be there. Accept करेगा इसलिए minus हो जाएगा, है ना? Again lithium here 1s2 2s1. So to become stable, it will either donate or accept. तो donate किया तो +1, accept किया तो -7. But here, which one is possible practically? So say to accept 1 electron, it is easy, but to donate 1 electron, it is easy, but to accept 7 electron, it is tough for lithium. Therefore, experimentally, in case of lithium, -7 is not possible. But +1 is possible. Correct? Again I am repeating. In case of lithium, +1 and -7 both will come. But to donate 1 electron, it is easy. But to accept 7 electron, it is tough. Therefore, here in case of lithium, +1 is possible, but -7 is not possible practically. Similarly, this is beryllium. Z is equal to 4, 1s2, 2s2. Now say 1s2, 2s2, so here 2p will also come. In which condition? Beryllium is stable. So whenever in case of P6 NH2 is there, in case of beryllium S में 2 है but P में नहीं है, इसलिए क्या करेगा? तो to become stable, beryllium will donate this 2 electron or accept this 7 electron. So whenever it will donate 2 electron, then it is easy. But to accept 6 electron, it is tough. So here, in case of beryllium, again, -6 is not possible. Same reason will come in case of boron. Z is equal to 5. In case of boron, Z is equal to 5. So 1s2, 2s2, 2p1. Now, here p orbital is there. In case of p orbital, electron is related with respect to this one, 1 to 5 range. Therefore, it is unstable. Therefore, to become stable, it will donate. So, how many electron? 2 plus 1. It will either donate 3 electron or accept 5 electron. But now, to accept 3 electron, to donate 3 electron, it is easy. But to accept 5 electron, it is tough. Therefore, in case of boron, -5 will not come. -5 will not come, but +3 is possible. Same condition will come in case of carbon. In case of carbon, Z is equal to 6. Here 1s2, 2s2, 2p2. तो क्या हो जाएगा? Now, देखो यहाँ पे 1s2, ये p ऑर्बिटल है, तो p में in case of p, in which condition it is stable? So whenever number of electrons are 6, but here number of electrons are related with respect to 2. Therefore, to become stable, carbon can donate electron as well as accept. Here +4 and -4 will come. But in case of carbon, both oxidation state will come. In case of carbon, +4 and -4 both are possible. Similarly, in case of nitrogen, atomic number Z is equal to 7. Again 1s2, 2s2, 2p3. Now again valence orbital is p. So valence orbital p. And this 3 electron is related with respect to this range. Therefore, it is unstable. So now to become stable, again it will donate this 3 electron. So whenever it will donate, then plus will come, and whenever it will accept, then minus will come. In case of nitrogen, -3 is there, and in case of C, whenever it will accept, then -3, and whenever it will donate, then +5 will come. In this way, we can find out correct electronic configuration from hydrogen to nitrogen. From hydrogen to nitrogen. Correct?